Right. Well, hi everyone. Happy New Year. Thanks for being here. Thank you, Johannes and Xavier, for inviting me to talk here. Um, as has been said, I'm Nadri. I'm a contributor to the Rust project. I've been mostly focusing on pattern matching in general. I helped implement some features and more recently design some features related to patterns. And I'm going to talk about one of them today, which is match ergonomics. 2.0, so then overhaul. The context is what we call match ergonomics, which is the following feature in Rust. We know, as in any language with algebraic data types and patterns, if I have an option of t, I can match on it. Option is an enum, I can match with the two variants of option. I can have a branch for some and a branch for none. And because sum has a payload, when I match on sum, I get access to the value that's contained in it, which is bound to x. And so the sum x on the left binds a variable x of type t. Match ergonomics is the feature whereby this also works if there's a reference to an enum or to a value in general. Patterns work through references in this specific way that here the sum x meant that x got type t. This is the t type that's declared in the option. Option, as declared, says, oh, this variant sum that has a type t. But here, when we go through a reference, Rust automatically allows this pattern and then binds x to a reference to t. And this is I'm going to explain how this works and why we did that choice. That's an ergonomic choice to make patterns more convenient. And the topic of my talk, I wanted to simplify this. That's not simple. The outline is without the bullet points. Here we go. The outline is I'm going to explain what match ergonomics is today in Rust with a bit of background about how it came about. And what happened about a year ago is that there's a particular issue about that people were surprised about how it worked that started a lot of discussion and a lot of design that made us rethink match ergonomics. And we're at today, and with lots of proposals and formalism, things happened over the last year in this area as well. Present some of it and explain where we're at for 2025. So the background is matches without match ergonomics. So you may not know, but match ergonomics was was a feature that was RFC'd first in end of 2016, early 2017. So Rust 1.0 did not have it. So we're going to see how it worked without. And the first background we need is one of the subtle distinctions in Rust between value expressions and place expressions. Rust, as we all know, is very explicit about where values are in memory. Many languages, most languages probably, don't really give you access specifically to the fact about where a value is stored. So Python or OCaml or Haskell, you just have a value and it's somewhere. Implicitly, it's stuffed in a reference, but you don't see it. In Rust, you see it. And so Rust distinguishes between values that are actually values and values that denote a memory location. So in this sort of silly example, I have a tuple variable that contains a tuple of values, and I get a reference into the first half of it and write to it. And what's interesting is that some of the expressions here are not values per se. So tuple.0 is not a value of type string exactly, because it doesn't make sense to take a reference, to take the address of a value. What we're taking the address of is the memory location. And the way Rust thinks about that is that it says tuple.0 is a place expression, an expression that evaluates to a memory location. And then I can take the address of that. That makes sense. And then once I take the address, this whole expression, the ampersand new tuple.0, that's a value. That's a new value we just created that contains a pointer. And so a lot of subtleties about Rust is that these two things exist and are mostly hidden away. You don't really see the difference between the two. So the difference, to emphasize, so the place expressions, they have addresses, they can be written to or read from, of course. And value expressions don't have a meaningful address, they're just a value that is not stored anywhere yet, but they can be stored in places and also passed to functions. But we don't see this distinction because Rust magically coerces between the two when we need. So most of the time, place to value coercion happens. So if I mention a place expression in a value where I'm in a somewhere, a syntactic place where, well, in a syntactic location, I need a value. For example, if I was passing this to a function or assigning it to a variable, then Rust will just do a coercion, by which it means just read the value. And sometimes the other coercion happens in the other way. So the distinction is not super known and not relevant to beginner Rust, but it's very important for us for matching because matches operate on places. And this is not well known, but this is valid. Here, star opt str, on the face of it, you might think, oh, matches operate on values. And so you would expect this to be disallowed because star opt str is trying to copy a value that is not copy. If I was passing star opt str to a function, that wouldn't work. But I can match on it. This is legal. And the way it works is that match expression, you give it a place expression, so you give it a memory location, and it will inspect the memory location the way you asked it to. So it will here inspect which variant is stored in this memory location of type option string. And depending on the variant, you can execute different code. This allows for a specific pattern that beginner Rust users don't know about, but ref x, where s is a variable, is a valid pattern. And what it does is that it gives you in S a reference to the underlying place, to the place we are matching on. This is, well, because of match ergonomics, we don't really use that. We would, if I was writing this today, I would have written this and things would have just worked. But the original Rust meant everything to be very explicit about references and dereferences. And so this was how you might write the pattern that looks into an option and takes reference to the contents. And this is what it looked like. So if I was matching on opt here, which is a variable, so it's a place that has a reference type, then the building blocks that allow me to match through references in old Rust, in Rust 1.0, are this ref pattern that takes a reference to the place we're matching on, and its sort of symmetric friend, the ampersand pattern, that dereferences the value. So as usual in patterns, we have this sort of symmetry between the way we construct a value and the way we pattern match on it are sort of the same. And so I construct a sum variant, I pattern match with the sum variant, and in the same way, I take a reference to something in the value space, and I to sort of remove a reference. In patterns, there's also this reference symbol. So this ref keyword is sort of double backwards. It doesn't really have a value symmetry, which is why it's a surprising thing, which is why it's often confusing and not something people use a lot. But this is Rust 2015. We have to use it. And it's a bit cumbersome. If you've written any pattern match, you know that this is not how you want to write it at all. You want to write it like you would in OCaml or in Haskell, where you don't even think about where the value is. You just want the contents. And so match ergonomics came about. RFC 2005 proposes the following simple idea. Well, the users probably just write some here and then get errors and have to fix their patterns. So let's allow some. So I'm switching to if let because match takes more lines. But it's the same thing. Here I'm pattern matching some X and something that's a reference. Well, RFC 205 says let's allow that. But for convenience, we don't want to just allow this and then try to give you an X here, right? If it sort of ignored the references and continued as usual, X would have type T, which is absolutely almost never what you want. Well, this can be argued, but that was a design choice. The design choice, well, probably we want a reference to the contents and not trying to copy the contents. So when I write this, two things happen. In terms of type checking, the type checker sees the sum and sort of tries to look inside the reference, sees there's an option and is like, okay, and then remembers there was a reference that was skipped so that we borrow the X again. And this is the basics, the heart of match ergonomics. This is the idea of the reference slipping into the pattern. If you have a constructor pattern looking at a reference, then the reference goes inside and you continue matching. In the de Shugot form, you can see the two things happening here. This is an equivalent pattern, the explicit one you would have written before this RFC, where you first reference and then re-reference because you remembered there was a reference around. So that was the design choice, is let's make it work in this way, which turned out to be very convenient with this sort of auto-borrowing of the variables inside. There's two more non-trivial behavior about this that we'll present before moving on to the more recent stuff. Part of this RFC is the question of what happens when I do have a reference pattern inside a pattern that uses match ergonomics. So if we follow, I will show formal rules later, but for now, informally, we said that sum matches on this sort of through the ampersand and remembers that there was a reference somewhere. And there was a decent amount of discussion about what to do if there's a reference pattern here. This reference pattern is allowed as per the previous rules, right? This is matching on the place of type ampersand t, so I can write ampersand x. This was something that was allowed in 2015. But we also have this remembered reference, this sort of virtual reference that we want to add. What do we do with it? Well, what was decided at the time after a decent amount of discussion is to reset. Oh, I forgot to introduce the name. The virtual reference is called in the RFC and in discussion, it's called the default binding mode. Why is it called that way? Because this ref keyword is called the binding mode. So there's three possible binding modes. There's just X is a normal binding mode or a move binding mode. Then there's ref that tries to take a reference to the place, and f mute that tries to take a mutable reference. We call that the binding mode. And the way match ergonomics works is that when we go through a reference, then we remember this default binding mode that by default, because we went through a reference by default, we put a ref. If someone wrote ref mode instead, then the default doesn't apply. And in this case, you get an error because you're trying to mutably borrow something you cannot borrow. So to come back to the reference patterns, when there's a reference, the default binding mode is reset. In other words, we forget that we will not re-borrow the X here. So we get an X of type T. This single ampersand is matching on this one, on this real reference that is in memory, and this reference that was sort of slipped into. That's one of the design choices, and one of the things that we're now really questioning as part of the design. And finally, the nested reference case is really cute when you think about it. Here we have opt with a bunch of references. Our option is behind a bunch of indirections. And then we match on it using match ergonomics. You might think that because we just put the slip references from the outside into the inside, you might think we get X with type ampersand, ampersand, ampersand T. But we don't, for one simple reason, is that if X had this type, then star X would have this type, ampersand, ampersand, ampersand T. That's a reference to reference to reference to T. But there is nothing like that in memory currently. What we have in memory is there's one location that has an option T, one location that has a reference to that, a location that has a reference to that, and like maybe a few more. But there's nothing that looks like a reference to a T, let alone a reference to a T. So there's nothing that this X of this type could point to and make it work. So whenever we have these sort of virtual references, we're sort of forced by virtue of what's in memory to keep only one layer of references. So references sort of collapse into a single layer in Ergonomics. And the sugared version, well, we have to explicitly go through all the 4 references, and then we just reference once. We can't do ref. That's not a thing that would make sense. You'd have to introduce a temporary, and that's not something we want to do in a pattern. So we get a single one. And that was Ergonomics as it is in stable Rust today. And there's a few more edge cases that we'll not go into. You can ask me at the end. And now what I will do is I will present a little bit what formal rules for that look like, and then I'll leave a little bit of space for questions, because I know this is a lot of information and maybe not everything was clear. But the way to formalize this is pretty straightforward. So this is a normal typing rule. You might have seen those. If you've not seen those, there's 2 ways to read them. One way is to read top to bottom and to say, if a pattern has type T, if a pattern P has type T, then a pattern sum P is a valid pattern for type option T. The way we usually read them, however, is in the other direction, because the other direction says, if I have a pattern sum P of type option T, then this is valid if pattern P is valid on type T. So the 2 rules here tell you how to type, the basic idea of how to type check patterns without Ergonomics. And they say, in our example here, we have sum of X on type option T. So we look at the rules. This one matches. So we know that this is valid if this is valid. So we want X to have type T, and then recursively we apply more rules. And this is a rule that has no precondition, so it's always valid. When I have the pattern X on type T, that's always okay. We simply, the binding X simply takes type T, and that's valid. I will now reveal one of the things I did. Well, the main thing I did, a tool I developed for this question, which is I made a web app to try and see rules. So this is the rules for the very simple no match ergonomics system. We have a binding rule that says X of type T, that's valid. I also have ref X. If I write ref X, then ref X is valid for type T if X is valid for type %T, and because of that rule, we know that's always valid. And here we have the sum rule, which in this case, I'm doing on tuples. I'm using square brackets to denote tuples. And so a tuple with 2 patterns is valid for a tuple of types if each pattern is valid for each type. And this is similar to what we had with sum. Here, I'm sort of ignoring the constructors. Oops, I meant P, well, maybe P something, I guess, or whatever you want to write it. I'm ignoring the constructors because they're not really relevant. I just need, for the typing purposes, I only need tuples. And so this is the complete list of rules that we need to match patterns in Rust 2015, in Rust 1.0. And the last rule I didn't mention in this one is this one. So when I have an %P pattern on an %T type, that's valid if P is valid for type T. And here we go. That's the whole thing. And there's also mute X, which declares a mutable binding. That's not that interesting. So that's so far without match ergonomics. And how do we do match ergonomics? Well, I said we track an extra bit of state. And the way it works is the way I decided we came up with this, this way of doing it was simply track the bit of state on the left. So this is a default binding mode, and it can take 3 possible values. It can be ref mute, or move. This is move. And the constructor rule simply works for any DBM and keeps it the same. But now we have 2 more rules. One rule is if the default binding mode is ref, then I guess one way I could write it like this. So if the default binding mode is ref, and I'm trying to match it to pattern match a binding on type T, then it's the same. It's valid if ref X is valid for type T, or as I had written it previously, it's valid if X is valid for type %T. And so, and this is the rule where when there's a default binding mode, we auto borrow any bindings. And this is the core rule of match ergonomics, which says if I have a sum P pattern on a reference type, then I remember that there was a reference we slipped into. So I make the default binding mode ref, so we can reborrow later. And then I just match P, sum P against T. And so in our example above, the first step, I could have shown it that, oh, I will show a derivation actually, that will be fun. All right, we're moving to this and to stable Rust. And the pattern we have is an X on type %T. So this is the equivalent of a sum X on type $option T. As I said, I'm ignoring it. I'm using tuples everywhere. So the way it works is we start with binding on move, and we have a constructor pattern. So that's the equivalent of a sum pattern on the reference type. Oh, I was doing 2 steps at once. Well, I was doing 2 steps at once. That's not fun. The first step is we remember the ref binding mode and we match this, and we end up in this rule. And the second step is we preserve the binding mode and match the underlying pattern on type T. So here we do that in 1 step for technical reasons. So we get to the ref binding mode and we have X of type T. And then we apply the rule binding and ignore this bit. We get X of type %T, and that's the final result of the type checking. The type checker tells us X is %T. And that's right. That's where we at about a year ago, end of 2023. We have match ergonomics working nicely, and we're starting to think how to change it. Does anyone have questions about what I've presented so far? I went a bit quickly, probably. Is the rules clear? Is anything I skipped over too quickly?
I can start with a question. The default binding mode, like what is it by default?
Well, by default, this is the nothing. We call it the move binding mode, which does nothing specific. In the rules, you can see, which one is it? Well, I guess that one just said for any binding mode X, its column T is valid. That's boring. Okay, well, the default one is move. You can see in the trace here, we start with move always, and it can become ref or ref mute. We're going to type patterns. Anything else? I just have a crowd of type theorists who eat sequence for breakfast.
I think you might be able to move on, and I definitely have some questions, but for the end.
All right, I will move on. And do ask questions in chat if you want, and if they're urgent, they can be read to me. Otherwise, we'll have some starting stuff for the rest for the end. So what happened is that so match ergonomics arrived in 2017-ish. And at the time, it was novel, and the feature design was rather conservative. But after a few years, people were very used to it and started using it a bit differently. And one thing that came up in a specific issue linked here is, well, oftentimes I match with match ergonomics and I obtain a reference. But often I actually want the type without the reference. I want to copy out. Often it's integers or booleans. I just want the plain value. And what patterns usually give me is that I can write an ampersand somewhere, usually, to get me the value. But in this case, it might not be exactly clear where can I put the ampersand to get me the value? And this depends on what the type of vec.last is, and if you're not super awake, you might not exactly know which to do. And the correct answer is that only this one works. Because this one, right, we get an option of reference, so this one is just simply false. And this one is not allowed because, as we said, the rule in match ergonomics is the $x pattern is allowed if the place that's being matched on has a reference type. But here the place has type U32, despite the fact that X is a reference. And so there's something that felt surprising to users, which is this sort of discrepancy between the fact that X looks like it has a reference type, and yet we cannot write $X here. And that comes up rather often when writing, just trying to deference, like writing code that has some copy types, that you just want to copy it out. This discrepancy was noticed. There's the issue here I'm linking to, opened in, I don't know, 2019, I think. And nothing happened for a while. And then end of 2023, the 2024 edition of Rust was coming up. And I thought, well, let's fix this. Let's see if we can fix this one. There's one or two issues related to this. And started thinking about how we could do things differently. The sort of obvious solution would be, oh, well, we know that the default binding mode of ref sort of works like a reference, right? That like the reason there is X is a reference type here is because there's a default binding mode around here that sort of becomes a reference. So one thing we could do is add this rule. This rule says when the default binding mode is ref, so when we're under reference, a magical the slipped reference, and I write $P, for a T that's not itself a reference, then, well, let's dereference the default binding mode. Let's dereference this virtual reference. Let's just treat this sort of fake reference like a real one. And then so we reset the binding mode and we match P against T. And so this would allow this case to work, because when we arrive here, we have a default binding mode of ref, and then it works like a reference. So this just eats the reference, and then we carry on and we get X of type U32. And this is where I didn't exactly know how to go about with the slides, but the idea underlying this, one question I want to ask is, well, actually I have a slide. The thing is, users don't see the binding mode. As a user, I see the types of things, and this very error, the very fact that as a user, I am tempted to write an $X here, this tells me something as a language designer. It tells me that maybe the references that users care about is the visible one, the one that is assigned to values and not the one that is exactly in memory. And so this solution of, well, let's just allow this thing, didn't feel good enough. And with the Lang team and a bunch of other people, we started thinking about, oh, let's go a bit further. Let's see if we can make it better. And my hunch was that we could do without the binding mode. And this is how we can, this proposal, I call it stateless. And the way stateless works is that it treats the virtual reference like a real reference. So for example, if I match, in order for a pattern of type constructor to be valid on a reference to the tuple in here, well, I simply slip the reference into the type. And so for this to be valid, it suffices for these two to be valid. So for a tuple to be okay on the reference, it's okay if each part of the tuple is okay on the reference to the internals. Notice how this is slightly different than before, because before we were still matching P on T, and remembering the sort of ambient bounding mode, which was a sort of ambient virtual reference. In this case, I'm being explicit, oh, let's actually pretend this is a real reference. And the other rules, some of the rules work exactly the same. So the binding rules are the same. This one, let's not have it. The reference rule are the same. And this time, because I'm actually taking this binding mode as a real reference, then this rule works for both cases we care about. It works for actual references as before, and it works for the sort of virtual reference. So it allows the case we had earlier, right? If we look at where we get here we're matching ampersand x on ampersand t, and there's just nothing about, there's no extra state kept. It's just, this is an ampersand U32. I can write an ampersand pattern to it. This is almost too obvious, and I think it is, but this sparked a lot of discussion. Here's the last non-trivial rule is, as I said, the way match ergonomics work is that we have to collapse many layers of references. And the way it is expressed in rules is that if I have a constructor pattern on a double reference, then it's just, then I match the constructor pattern on just one layer of reference. So I collapse. When it's mixed mutability, I also merge mutability. So if it's on ampersand mute, I get ampersand mute. If it's either, then I'll get a shared one. And this completely describes one particular approach to match ergonomics. But not everyone agrees that this is the best, and there's been a lot of discussion. The sort of main contention, the crucial thing is in this one, in this proposal, what we care about first is the type here is the type in memory. It is the type of the place we're matching on, and the virtual type is sort of only taken in consideration later. In my proposal, which I have dubbed stateless because it doesn't have a binding mode state, the reference, we always match we always match the reference type first. And this sort of corresponds, this reference might be the binding mode virtual reference. And this makes a difference. And you can see difference in behavior. So let me go in compare mode with, so this is the competing proposal, this is RFC 3627. Let's see some differences. We don't need that much. We don't need that much. Here's one different. Wow, that's not a fun one. One without ref. Do we have any? Maybe. So here, in this case, let me recall what was happening here. We're matching a constructor on an ampersand thing. So the reference slips in on the inside, and then we match the ampersand x against the ampersand mu t. In the binding mode view, oh, well, there's too many rules here. Let me not do that. Yeah, in the binding mode view, we care about the in-memory type, the type that's actually inside memory. And that type is an ampersand mute. And so I cannot allow an ampersand x and ampersand mute. So this is an error. But in the let's look at the outer type first, which is my proposal, then this ampersand x will be matched against the virtual reference first, which if expressed in, well, let's not switch now. And this is red because it's a diff, but ignore the red. If we just match the ampersand x against the sort of virtual reference first, then this is fine. We can dereference it, it goes away, and then we just get x of type ampersand mute t. You get a move error because we're trying to copy a mutable reference, but that's expected. It's the same as if I had written the ampersand on the outside. I also get the can copy ref mute. So this is the crux of this sort of the design disagreement is, well, should the pattern match what the type actually looks like in the type declaration, or should the pattern match what the type that the user sees? And well, we're slowly converging. There's lots of discussion on this. The current status is the following. Edition 2024, we partially removed March Ergonomics. And like specifically, we disallowed, we said, which one is it? The ampersand rule, which one is it? The ampersand rule, whenever there's an ampersand, and the binding mode isn't the default one, then that's just an error in the, oh, I can compare. Yay, okay. Stable Rust and min ergonomics, I think it is. Ooh, that's fun. Yeah, if I have an ampersand T under a non-default binding mode and a non-move binding mode, then that's just an error in 2024 today, right? So we just removed a bunch of rules that were allowed in March Ergonomics to allow for change. Why? Because, well, one of the proposals, like my proposal says, oh, well, this should be ampersand T here. The other one says, oh, it should be ref here. And so the main competitors are this RFC 3627 that sort of extends the binding mode view and add more features so it works a bit more like we want to. And I propose to overhaul it a little bit more and do the sort of stateless thing I said, where we only care about the, we don't track any other state than the virtual reference, than the type, and we just slit references in the type. Many details I haven't mentioned as under discussion. It's being implemented, so we can play with it. We're discussing RFCs and how to phrase this, and lots of annoying deep edge cases I haven't mentioned. The considerations were sort of stacked between, like, pulled between the mental model should be sharp and ideally with as little state as we can, but we also want the code to just work, right? The point of match ergonomics is that users shouldn't know, or shouldn't have to think too hard about exactly what's happening with references. They want their pattern to work. That's in tension with the first point. The third point is this idea that people write code incrementally and usually just see the types that are present in the editor or in the type errors. So this informs, well, the view I'm pushing forward, and I'm not exactly the only one, but I'm the main one. This incremental view that takes into consideration the visible types and not the hidden ones. But there's a tension with, again, this one, a pattern should reflect the type it matches. If there's an ampersand mute T in my struct, then I want to match it in this way. So we're a bit stuck. There's a big design point here, and there's also a big consistency point. And lots of formal things have been done. I'm out of slides, and I have a bit more time. I think I will answer questions because I haven't probably covered everything that was interesting. So, okay, I'll do a summary and I'll rapidly present the tool and then go with questions. So the summary of what we talked about today is that matches operate on places, and in general, Rust is unboxed. So it has explicit references, and this is the source of the whole topic we're discussing. Match ergonomics were an attempt to make this easier, and that worked really well. And now we're sort of questioning the whole thing and hopefully slowly converging. And we ended up, I should add a point, like we ended up developing formal models and tools. A lot of people were involved. Most importantly, TC from the Lang team, Jules Berthollet, and myself. We alternated implementing tools and formalisms and pushing for proposals forward. And the Lang team had like maybe 5 design meetings on the topic. Waffle and Diane helped. Diane is helping me, is helping with the implementation right now. Many others. This has been a long thing going on for more than a year. And to present sort of the tool where I'm at it, so this is a tool so the TC first made a little a command line tool that looked like this. You wrote it was command line, but now integrated in the web app. You give it a pattern and it sort of goes step by step. And so I did my own version, and then I turned it into web app. And the idea is that these are all the different sort of points of design that we're discussing. Some of them relate to whether we're considering the inner reference or the outer reference. You can click on things to have more options. This web app is accessible. I linked to it in the description for today's talk, by the way. And there's different ways of seeing the rules. So, for example, can I have stable Rust? No, stateless. Okay. The ref view of seeing the rules tracks the binding mode on the left. The other my way of seeing the rules tracks whether the reference here is a real one or it's a sort of fake inherited one, and that changes some rules. And then we can compare rules, and this is the mad thing that just diffs rules and automatically computes like nice diffs. You can also have a compare mode that can check whether left to right is compatible or not by exhaustively listing things. I had a lot of fun with this. Do play with the tool if you wish. This has been tremendously helpful in actually figuring out what was compatible with what and what was breaking and what the changes were. This is the sort of the diff between the two main proposals at the moment. And you can see there's this tiny things like, oh, here there's a ampersand mute becomes an ampersand in this one case, and then this other case where also a slight difference. It's extremely subtle, but fun. This is where I'm at. Thanks for listening. I am very open to questions. If I missed anything you were interested in, I can explain more things about the web app. I can explain a bit more the other proposals. I will probably not go into the ref patterns because I don't feel I feel like there's enough to cover already. Thank you. Please, questions.
I have a question about these different views. So you have this stateless proposal, and then you have these views with inh and ref. Are there like because it seems in your system you just in your stateless version you just add some ampersand somewhere, and it seems surprising that you can actually it seems, is it equivalent to one of these views with the references on the left?
So these are just different ways of showing the rules, but the rules are
then they end up typing the same patterns.
Yes, the typing is exactly the same, and the bindings end up with the same types. So this is the way to express the stateless proposal in the binding mode view. So the way it works is, for example, here, if you wait, no, this one. This is not as precise. So the rules are automatically computed, so they're not like extremely precise. Okay, this is the one I want. If I match a constructor pattern on the reference type, then I do get a ref binding mode, and I still match. So the difference is what the T means. In this view, the T is the underlying T, that's the one that's present in memory, the T we're matching against. In this view, the T is the virtual type, the one that the user would see. So the way the stateless proposal work in terms of the type in memory is that, well, with the type in memory is not changed. We're still matching against T0, but we remember the ref here. And then when we have a ampersand pattern, it might, and there's a ref binding mode, it will eat it. So this is a more complicated way of expressing what is neatly expressed in this view. And vice versa, if you try to express the sort of stable Rust rules in this view, it gets a bit more complex. There's a lot of different things happening because, for example, the ampersand, right? So the ampersand pattern will change behavior depending if the visible type has a real reference or a fake one on the outside. And so if there's a fake one, it will eat both references. If it's a real one, it will only eat one. Here's the rule with the real one, right? If there's only a real one, so that's a real reference type, then only one reference gets removed. If it's a virtual one, inherited reference, then both get removed. So that's
Okay, thanks.
I think Brian had a question as well.
Yeah, so this is a very speculative question, but there's a fun paper last year from some folks that were called for generalizing matches even further. I think the title is The Ultimate Conditional Syntax.
What is
It's
that?
just
What's the title of the paper?
The Ultimate Conditional Syntax. Here's a link.
Okay, fun.
Yeah, it sort of combines conditionals with the ability to execute code along the way, and they have some cute findings and a nice talk on how it can simplify a lot of things. But I was just curious, as somebody who has already put a ton of work into, optimizing what's currently there, do you think this falls on the like absolutely never going to happen, very unlikely to happen, or yeah, maybe someday?
I really would have to read the paper because I don't really know what it's proposing. Yeah, I would have to read the paper. We can chat. Come chat on Zulip if you want. On the Rustlang Zulip.
Sure, fair enough.
Sounds interesting. I'm happy to discuss.
Are there any other questions? Otherwise, I have so many questions.
Yes.
So one that's a personal bugbear of mine, which is I mean, you mentioned you weren't going to explain it at the moment, but do you have any idea how deref patterns would fit into this? Because I really want deref patterns in Rust. They would make compilers so much nicer.
So the context for everyone, deref patterns are the idea that we want pattern like types like box or arc, types that have deref that you can deref through them normally. We want them to work in patterns nicely as well. And well, I think they fit really well with my proposal, obviously, and not as well with the other one. I had a slide for this. It's heavy, but the idea would, whenever there's a reference type, what if we just added, like, allowed it for any deref type? And it sort of works. It honestly works pretty nicely. And then we can just write %p on a box, for example, or a vec. That's even better. Look, here I could write %p on a vec and then get my p to match on the slice, on the underlying slice. And we can even make it implicit, right? So the same way match ergonomics allow you to implicitly go inside a ref. Well, maybe I could just write a slice pattern on a vec. And then the rules would say, well, for this to work, you would just match the slice pattern against the ref of that, which is a mutable reference to a slice. And then you would just match the pattern normally. There's lots of questions. One of them is how to deal with mutability. How do we choose between mutable or not? There are some answers. We might want to be forward compatible with the ref move if we one day get that. People don't like arbitrary user code running implicitly, so some people are not fond of this proposal. Roughly, I think it feels really well with my proposal, the sort of the proposal that looks at the user visible type. That fits well in it, so that's part of why I'm excited about it. But at the moment, the deref patterns is a bit on hold while I'm working on the other things. And hopefully, once we get settled on match ergonomics, I want to come back to it and make it work. It is a half-baked implementation in Rust C if you want to try it. It uses explicit syntax though. Does that answer the question?
It does very much. So I hope your proposal wins.
The other one could also work. Like, could be made. Yeah. Both can be made to work. But
I'm sure. Go ahead, Johannes.
Yes, thanks for the talk. I had the question of how all of these rules, I mean, for example, the rule you just showed is like, I would guess, a bit non-deterministic, right? You like have different choices of whether you like want to look for a deref implementation on the type and apply that or not, or maybe
they're all completely deterministic.
They are completely deterministic. Okay, then I guess maybe my question still is, how does this all interact with like type inference? Is it like, how possible does this make it for the type inference to go wrong because it like unifies something somewhere in a wrong way that I didn't actually intend it? But I mean, right, this is my understanding of how Rust type inference works, right? It does simply Milner-ish based things.
So the way we implement it, any of this proposal will be implemented in this sort of in this sort of view, right? We will track some state and look at the underlying type, and this poses no problem for type inference today, and that won't change. The way it's done is that well, it makes annoying errors sometimes. The way it works is just that if I see a sum pattern, or if I see a constructor pattern, then I will ask the compiler to tell me what type it is. And if it does tell me what type it is, then if it's a reference, I can do this little dance. If it's not a reference, I can do this little dance. So that poses no problem, and we just keep track of the extra references we have to add, and it all works well. The part where it doesn't work well, and I hope we can fix that by sort of orthogonal, is that if I have a pattern like this, like a sum pattern, and the type is not yet known, probably because of a type error, then by default we will choose this. We'll choose this case. Well, this one, sorry. We'll choose this. So we will just assume that the patterns are being matched on type T0 with no binding mode. So a type like so if I have some X on something unknown, then by default, then X will get type maybe U32. If it can't infer so that far, it will tell it, oh, it's probably U32. But it might end up being ampersand U32 in the real code because of some reference it hadn't seen yet. So the problem today is that when there's type errors around, we do infer the wrong type sometimes. And that makes for very annoying errors where it tells you, oh, you're trying to move out of a thing you can't copy. You're trying to copy something you can't. And no, you didn't. It's just there was a different type error. So then you fix some of the code and it makes everything worse. I hope we can fix that. But apart from that, the way it's implemented works pretty well. We never use ergonomics to unify is the short answer. And so when we do know the type, we can progress. Otherwise, we make wrong choices. Does that answer the question?
Yeah, I guess that answers my question. Yes.
I have another question, but more about, unless somebody else has a question, I would happily yield my time. But it's more about the sort of like it's like a meta question rather. I was just wondering if you could talk a little bit more about like I don't know. I think this whole project is like a very, very cool and pragmatic application of formal methods, like with a nice UX and everything. I was wondering if you could talk a little bit more about like how the impact that had on this whole discussion, on like how it was received by other language people, how it was received by people who don't necessarily have like type theory experience.
That's a great question. Yes, it was very nice. So the first thing that happened, the initial thing was TC, so one of the Lang team members, initially what he did is he wrote a proposal in the form of making a state machine explicit, right? So this is a simple state machine where there's sort of transitions between the different states of which binding mode we're in. And he made that explicit in terms of this is the state machine we have today, and this is how we could tweak it and trying to argue for which was more natural. And that helped a little bit, just because at least we had a clear picture of what was happening. At least we had a model, and that helped. But then I think it took me a while to come up with the typing rules. What I came up with initially was this version, which I think is quite cute. Is that I can track the expression here. And tracking the expression gives me all information I know. I can deduce the binding mode from the expression here. Let me find the deref rules. So if I have an ampersand t and an ampersand, no, that's not the one. I need the constructor ref. Yeah, all right, this one. If I try to match through a reference, then it's the same as matching this P on the reference T. And then the sort of the expression that's being sort of assigned is also updated, and using that I can track lots of things. So I was just trying to reason on that for a while. But I don't think the writing it as rules was the most helpful. What was the most helpful was developing a tool that people would try and compare things with. At the point that TC came up with the state machine, he wrote a tool that was extremely helpful in just running through examples. And then I wrote my own tool that had a compare mode, and that was also extremely helpful. The rules were helpful for, I don't know, I feel like we didn't quite get the Lang team to read rules in this form, unfortunately. Or in either of these forms. We both sort of tried, but I think it was more for us. It was helpful for TC and me to be extremely clear about what we were talking about. So we were the main ones designing things, and that was a tremendous help in terms of being clear about what we were saying, very simply. And also, actually, I should say this. I've mentioned that there was these two ways of seeing the thing that depended on which type we cared about. This for me was the sort of tipping point in terms of it understanding what the discussion was about, why we were in disagreement between TC and I. And this came up because of the rules, right? And so for the designers, for both of us designers, those rules were just a tremendous help. It just came up that we had to be precise. And that was the best. Like once I have a background in type theory, so that came naturally, writing it that way came naturally, and TC found it extremely helpful. He had not seen that before, as far as I can tell. So yeah, big win in terms of knowing what we were talking about. We were arguing past each other before we went down to this level of precision. I think is my does that answer the question?
It does. I guess I would have we're running out on time. I guess I have like one sort of minor follow-up, which is like if you could take like a lesson out of this experience, like for some future discussion on changes to the REST type system, like how would that influence like your approach to another problem? Would you like, I don't know. Do you feel like basically we should be building more ad hoc tools like this for, as soon as somebody's like, or maybe not as soon as, but like somebody wants to change trait resolution? Well, we just need to build like a mini trait solver where you can write rules and see what happens or something like that.
Honestly, yes, 100%. Like I would do two things in order. The first one is define precisely what, just define a precise model is the first step. And step two, try to have a tool that runs it. I cannot tell you how helpful it was once we had written. It wasn't hard to go from we have a basic tool that does the thing to have the full tool that has a compare mode and like diffs things, and that was just a fun engineering. But it changed my life. So yes, and also what you just described is like Nico is trying that already. It's sort of that's Nico's a mere formality plan is to have a sort of toy trait solver type system that we can play with. And I agree with him on this, that I think it will be extremely, that's how you can move fast, is you have to have something that runs it for you. The level of precision we can't run it in our head very quickly. So yeah, we'll just do more of that. I'm quite happy I've done that.
All right. Well, thank you very much. I don't know if there's any final questions from anyone. I think we can take one more short question. Otherwise, I think we'll close it out. And Nadri is, of course, available on Zulip to, I think, talk. I'm not that I'm volunteering him or anything, but I see him around on there, so I think he would be happy to talk about these things in a more async manner as well.
Yeah, perhaps as a follow-up question, if I wanted to now start also work on those match ergonomics rules, what would I do? Is there a call to action here? I don't know.
If you wanted to write on, so if you want to help with the implementation, do talk to me. If you want to help with the design, do talk to me. These are so far mostly conversations, one-on-one conversations between interested people while we sort of iron out a proposal that looks good, and then at some point it will become an RFC. And most likely there will be Lang team design meetings. Those are open, so you can you can attend and like chat. But probably think before, like do chat before if you have any ideas or anything you want to push forward. If you want to help write the RFC, that would be extremely welcome. Or just iron out some details. Yeah, just chat. There's not really like a public discussion forum on this topic quite yet because there's only like 3 of us.
Okay, well, thank you very much again, Nadri. I think this was a very, very cool talk. And I don't know, I'm really jealous of this tool, even just for like when I write compilers, for my own languages. Like I should just start writing tools like this just for my own sanity.
I gotta say, I was really amazed that this is in Rust, right? I wrote all of this in Rust with a tiny front end, and this was very easy. So I recommend.
Yeah.